All right. And one thing I also wanted to ask, has anybody received there was an email. Oh, well, I think that's usually, I think it's usually on Canvas as well. I'm not exactly sure because I don't see what you guys see exactly. Mine looks a little different than yours. But let me do something over here. But I don't know if you guys are aware that they have been making some computers available. I think they usually like Chromebooks. Um, I'm gonna post on the chat. I'm gonna post a I'm gonna put a website that you can go to if you're interested on getting a free computer. Like I say, I think it's a Chromebook. Apparently they have so I put the link up there. You can click on that and or you can just copy it and paste it into your browser. You can go there. Apparently, one of the issues is that you have to make sure that so like if you like say if you're on Google, you need to sign out of Google and then go into the Southwestern College Google, Google, what do you call it, Google Drive, and then you can there you can apply directly. And so like I said, they already gave up 400. They're waiting for full funding, so they're gonna make a whole batch available. So once you fill out that form, uh, uh, they they're going to process it, and you may get in a new laptop, uh, probably a Chromebook. But so again, for those of you who have any issues, I know a lot of you just use your phone, but if you much rather have a laptop to use it for the class, then that's available. And they'll probably be making more available as we continue with this. But that's going to be happening in the summer as well. Everything, all the face-to-face classes are now going to be online as well, at least until the fall. They're even thinking that the fall is probably going to be uh, also all online. So, but anyway, so I just posted a link as I know so like say the best thing. I think you may be able to, when you see it, you may be able to click on it directly. I'm not sure if it works. Since I put it in, I'm not sure if it will work. I'm also going to try to put it on Canvas, but again, you have to go into Google to be able to access the form and all that. But again, for some of you, that might be helpful to be able to get a free laptop. I think they're giving them away. I don't think they're lending them. I think they're just giving them away. So, and from what I understand, it also includes they have this thing called MiFi that creates hotspots, and you usually have to pay for it. But apparently, they're giving you 3 months for free if you once you get that laptop, and they give you that. It comes included into the process. So anyway, I'll let you know. One of the deans just send these. Make sure to remind students about this. And they have already given 400 of them, so it's real. It's out there. Okay. All right, guys. So, is any question about anything, assignments? Hope everybody's doing well. I'm gonna go ahead and get going with. Like I said, we pretty much ended with hurricanes last week. Or Tuesday. I think we're just gonna move on. We're talking up about all that stuff. So the next, we're gonna go into climate and climate change. That's chapter 8. If you notice again on Canvas, I have updated the lectures as well. They look a lot more like a PowerPoint. They just put a PDF and they look in color and everything. You know, the idea, the ones I had before, the idea was that you can print them out and take notes while you're in class. Well, you can, they're still there. If you really want to do that, print them out and take notes to go along. You can always do that. But now you have this option as well to just have kind of like a PDF of how the PowerPoint actually looks like. All right. Okay, so if there's nothing else, again, remember you can post questions or put questions on the chat group, the chat area, and I'll answer them as I go along. All right. So let me go ahead and put the PowerPoint on. Make sure that everything is functioning the way it's supposed to be. So let's see. Okay, so do you now see the screen with chapter 8, climate change? Yes?
Yes.
Okay.
Yes.
So, yes or
Yes.
no?
Good morning.
Good morning. So you do see that, right? So you see the PowerPoint now?
Yes.
Okay, good. All right. Okay, so let me go ahead and get started then. The usual deal. So some of the key questions that we have for climate and climate change is what kind of information do you need to classify the climate change location? So we're going to look at this classification system we use to classify climate. Um, uh, Things like, for instance, why is that? And we already know some of these based on what we learned from pressure systems, when we talk about precipitation. Why is it that the tropics are warm and rainy? Uh, why do the deserts form and where do they form? Again, we know some of that already. We know about mid-latitude locations that have mild winters, while others have severe and cold winters. So we're going to see perhaps a little, we talked a little bit about already about how we have, for instance, our area that is a certain type of climate called Mediterranean, that is, it rains in the winter, but it's dry in the summer. Where we have other places, particularly, and again, it depends on the coast. We have that on the west coast, on the east coast, they tend to be rainy and can have what we call winters, and in some cases severe winters, and relatively hot summers. So we'll see some of those reasons why that happens based on this classification. We're going to look at why is it the polar regions are cold and dry. So again, we're going to have to also sort of do a brief sort of review of what we learn about pressure and what we learn about precipitation. And we're also going to start looking at the whole idea of climate change. We're going to, so I've been talking about it in different contexts based on what's happening to the imbalances that are being created in the atmosphere. But then we're going to start looking at the evidence. I know, unfortunately, climate change, many people are not looking at the signs. So I'm going to show you the signs of what's happening with climate change in more depth than we have already seen. So far, we have only looked at the changes in the atmosphere. But we can also put it in context. We can see, okay, so there have been periods that have been really warm through the history of the planet. Let's look at those, and we can look at it from different perspectives. We can look at it from the modern age, modern era. We can look at from like the periods of like 1,000 years, and we even have ways that we can check what climate was millions of years ago. And so we're going to look at those, and then look at some of the possible consequences and what we are already seeing with in terms of climate change, and particularly with global warming that is being caused by increases of greenhouse gases. So again, we're going to pretty much get that to look at the current state and where are we in terms of climate change. And, hopefully, again, these has unfortunately become very politicized. A lot of people tend to forget the science, and then they get into politics. But unfortunately, politicians are the policymakers, are the ones that can change things. And unfortunately, they can also be the ones that can continue to uh, 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 keep the status quo, so to speak. That that we're not going to get changes in the stuff that we send up in the atmosphere that continues to make these changes happen. So here's a quick outline of it: the classification of climate. We're going to understand within this classification, climates are usually grouped in and they identified by letters. Now, when I show you the classification that we use, you are going to see that there are sub-classifications and sub-sub-classifications. So I'm mostly going to want you to understand, to learn the major classification, like Group A, Group B, and that kind of stuff. We know that the Group A's are going to be tropical humid climates. Group B are the dry climates, mid-latitudes, which is where we are. Those the ones that apply to us. Now, this is the only one. The Group C is the one that apply to us. And there, I'm going to want you to know the sub-classification. The only one that I want you to know sub-classification will be for us. What is our actual letter, the sub-classification that we have here in the San Diego region, the Southern California region. So that's the one that I want to know. The rest of it, I only want you to know the difference between a Group A and Group B and so on. I'm going to walk you through each one of them and talk about some of the main sub-classifications, but you need to make sure that you at least know ours, the one that belongs to our area here. The classification are severe. We look at E and H that are polar and highland climates. Anyway, so we all understand all that stuff about change, the causes of it. And I guess but I think what is important to understand with climate change is that we're gonna see the one that most of the scientists now agree that is causing the climate to change are anthropogenic and caused by people. But also, like just to make sure you understand the science, I'm gonna show you things that actually cause they warm the planet, particularly warming naturally. And then we're gonna see, okay, you have that evidence, and you're gonna have to make some decisions as to the science. What is it that is what in your from presenting you from all the facts, you can understand why is it that it's actually happening and why the most predominant evidence is that we are causing it. Things that we as humans are doing is what's causing this problem, right? So quick review here. You guys remember the difference between weather and climate? So again, you can type in on the chat and, anybody perhaps tell me, would make perhaps with one word. What would be one word that you can use and to differentiate climate? Yeah, Carlos. Yeah, so definitely climate is long term, right? Weather is short term, right? That's one easy way to simply tell the difference, right? So weather, for instance, is present. As 3-4 days ago, it was pouring rain over here. Cloudy, it's been cloudy for seems like most of March, and all of a sudden, it's nice and sunny and warmer, right? Well, that's not gonna last. By the way, we have another storm coming. Probably by the weekend, we'll probably have it here. But it doesn't look that big, but things change. So, like Carlos said, you're correct. Weather is a short term. Today, what happened today is going to be different what happens tomorrow. It's different what happens for the next day. So that's changing all the time. Climate, on the other hand, which is what we're going to be looking at today, is it can give you an average, so a longer term, right? Patterns, you're going to see seasonal patterns. It's going to be more gradual change. We're going to be looking at things on the long term. We can measure, let's say, the average temperature a year, average temperature in a month, and so the changes in climate are going to be more gradual, and they do change. But they're going to be perhaps like what we've seen today from compared to hundreds of years ago. The climate is very different. Some areas have gotten drier than other areas and so on, right? So climate is going to be a lot more long term, but for that reason, climate is a more accurate way to tell us about something about a place. Some specific characteristics about a place are determined better by climate. In fact, and then you can look at other things like biomes, vegetation, and let's say, unfortunately, we're going to have to skip chapter 10 that talks about biogeography, but vegetation is the vegetation that you have in a particular area of the world based on the climate that they have is very telling. You can see patterns of vegetation and so on by the type of climate that you have in that area. So climate helps us understand a place a lot better. So this could be the weather that we have in Las Vegas, as you can see there. And it actually, I think it was last year that it snowed. I mean, we have even had a little bit of snow here 3 or 4 years ago. And so it could happen. We could have really icy conditions in Las Vegas, uh, on a given day. But most of the time, it's probably going to be like, it's going to be warm. It's going to be dry. Just most of the climate, and when we get to look at the classification of the climate in Vegas, it tells us a lot more about what it's actually like on a long-term basis, right? And again, like same, you can say, well, I just put Vegas out there on with it, but you can say the same thing about any place. Some days are going to be very rainy, other days are going to be very dry. But on the long term, what when you get the averages, when you get the aggregate of a particular place in terms of weather and in terms of precipitation and so on, temperatures, it's going to tell us a lot about the place. All right. So again, we talked about this before. If you understand the difference between weather and climate, you're, like say, far ahead in some of the public officials that remain nameless. So anyway, let's look at the classification system that we have. Right? The classification system that we have is called the Köppen Climate Classification System. This is the one that is used pretty much globally. It's the one that everybody in the world uses. There are a few others that, I'm not even going to mention because they're not working. This is the one that people use. It's named after the guy that you see in the picture there, Vladimir Peter Köppen, like a Swedish, Russian. He was a meteorologist, botanist, and geographer. So he basically began to look at patterns, average. And again, we're looking at climate now, so we need to look at long-term average values of temperature and precipitation. And then he figured that those patterns of temperature and rain and precipitation will give regions of the world particular characteristics. Now, he was also a botanist, so he would notice, for instance, vegetation patterns would be very different from place to place. Things will be different type of vegetation or lack of thereof. There's nothing grows in the polar regions or in the deserts, or very little grows in the deserts. And so he noticed that vegetation patterns would tell us a lot about a particular area. Now, so this system is made up of basically groupings. Each of the groups has a letter. There are 4 of the major groups that are simply classified by temperature, right? And the last, another group, one of the fifth group is classified with precipitation. So this is, very, very likely a test question that I would ask you. What are the 2 factors that determine the Köppen climate classification system? And this, again, those are going to be averages, usually annual and monthly values of temperature and precipitation. So again, the 4 major groups are usually classified, they have letters, and they're classified by temperature. And one group is exclusively by classification, by precipitation. Now, there are going to be subdivisions within each one of them that are going to be based on different levels of temperature and precipitation. So it will be combinations of that will sub-classify them. I'm going to show you the chart in a minute here. Now, very recently, in what is called the modified Köppen system, a new classification was added, and that was the age classification. So I mentioned that there were 5 main groups. Well, there's a 6th one now that was added, and again, it's very recent because remember when we talk about temperature, and we talk about how the higher the elevation of a place is, you can actually calculate the change in temperature that's going to happen as a result of elevation. So the areas in the world that are mountainous, they have mountains, and of course they're going to be higher elevation. So they pretty much have their own climate pattern simply based on elevation. And so mountain areas around the world um, 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 are usually going to be classified with age because of that, because they simply are, due to their elevation, they're going to have a peculiar set of characteristics. So let me show you the chart. So here it is. So this is the whole system. And you can see the main groups, A, B, and C, B, C, D, E, which is, this is going to be basically, it's going to be very dry and very cold. And then, of course, the age that I was telling you about, they simply just got added, right? So again, the first 5 major groups are going to be A, B, C, D, and E. Those are just the general classifications for climates around the world. Right below that, you're going to have a sub-classification that is going to be largely determined by levels of rain, the amount of rain that you get in those places. So again, so let's say you have an A, which is, I'll explain what each one means. And the description here tells you it's a tropical humid climate. But within A, there's going to be AF, AM, and AW that basically indicate different amounts of rain. So some areas are going to be wetter than others. Right? It's still going to be very tropical, very humid, very rainy, but some are going to be even rainier than others. So the second letter that is added, usually, and the same thing with B climates, the second letter usually means some are a little rainier than others, have more or less rain than others. And then there's a third classification that has a third letter, and that usually has to see with either more precipitation or temperature as well. So a combination of those things that has the third letter. Like I say, I'm gonna go through the main patterns, basically compare the different groups. You don't need to memorize every single classification type, and particularly you don't need to memorize the sub-classification. However, this section right here, the ones that are sort of pointing out right now, the Mediterranean, CA, CSB, right? This is our climate. This is the climate that we have here in San Diego and in Southern California region. So this is one that I would want you to know. And again, it has two levels of sub-classification. So you need to know that here in San Diego, we're going to have a CA, a CSB type of climate. It's overall, it's called Mediterranean. And I'll explain, it's very unique. We happen to be very fortunate to have this particular type of climate. It happens in very few places in the world, but this is ours. This is the one that we have. That's the only one that I'm going to want you to know. I am going to give you general characteristics of each one of these, particularly with the tropical, the marked differences in precipitation patterns. But I don't expect you to. I do expect you to know what happens on B climates. What are some of the general characteristics of B climate? But not necessarily know the difference between BW H or BSH or not. Now, if you're taking the lab right now, if you're going to take it in the future, you are going to have to get, and when I teach the lab, I have an activity where people have to give you a bunch of charts with temperatures and precipitation levels, and you have to actually determine what actual classification, including the sub-classification. All right. So again, I'm going to go through each of the main ones, A, B, C, D, E, and H. And I'm going to, those are the things you do need to know, that you need to remember them. Not necessarily memorize them, but you can remember the letter, the letter of the main group. That's what I expect you to know. All right.
Yes.
It looks overwhelming when you first see it, but again, the way I'm gonna break it down by individual group, and I think you'll see that it's a little more manageable. All right.
So we're, just a question. The classification is B for San Diego, right? Dry?
Please, no. Like I said, what I was saying is that the climate that we have here is C. We are part of what is called mid-latitude climates. So we
Okay.
are the sea in general, but when you break it down, we're actually Mediterranean. You know, like I say, if it wasn't for the ocean, we would be a desert. We'll be in the D category. Happen to
Okay,
have,
so we have, is C actually? C?
yeah, so we are C.
C, okay. I thought you said B as
Oh,
a
C,
boy. I'm sorry.
pasa, yeah.
C, okay.
CSA, CSB are the climates that we have here. Is the Mediterranean climate, the one that I'm pointing out right now with the arrow. That's the one. By the way, do you guys do see the arrow when I go like this? Do you see
Um,
it?
I'm kind of blind, but yes, I do see.
Yeah, because I know I should probably change the color. A little bit.
Yeah.
So, does everybody? You can tell me in the chat. Does everybody see the little? I have a little pointer, so I see it in my screen, but I want to make sure that you guys see that as well. Yeah, you see it. So that's when I point. So like say here, if you look at the Mediterranean, you can see CSA and CSB. That's the climate that we have.
CSA and CSB.
There are
Okay.
some more a little bit in America, but like you say, we need to learn the main ones, the main numbers, A through H, and then with the exception of and again, I'm going to talk about all of them, but
Oof.
specifically CSA or CSB because it's the one that we have. Right. So now, here's a few other things. Briefly talk about this before, but now here's the tool that we use to look at the climate of a particular area in the world. We use what I call climographs. Climographs, as the definition says here, is a diagram that shows the average monthly temperatures as well as the average precipitation. So the temperatures are shown as a graph. You see that graph right here in red? So for this particular area, St. Louis, Missouri, okay, you're gonna see what are the, and you can see on the left, you see the temperatures. You see them in both Celsius and in Fahrenheit. And on the right, you see precipitation pattern. You actually see them in inches as well as in centimeters. So the chart, the red chart, the graph, the line graph right here shows you the levels for every different month. Now at the bottom you see JFM, so January, February, March. So you see each month, and it is broken down by the 12 months of the year. So you can see that what the chart, what the line graph shows you is what are the temperatures for every given month, average temperature, remember these are aggregates, for the entire year. So you can see, for instance, in St. Louis, Missouri, that is going to be really cold in the winter. The temperatures are going to get down to freezing levels. Right? But then you start moving further out into the spring and then to the middle of the summer, June and July, you're getting temperatures in the 90s, close to the hundreds. Right? So now, from what we learned before, and I can see them, I can show you the map, you see the red dot right there? That's what St. Louis, Missouri is. And from what we remember from the past, what would you say, remember we talked about the factors that determine pressure, that determine precipitation. What would you say is happening here in St. Louis, Missouri? Where is it, by the way? I mean, where you see the dot. Where is it in the United States? Is it in the coastal region? And again, you can type it out over here or say it. Is it in the coastal region or is it in the continental region? Remember continental versus maritime? And there was questions that I put that in the last exam that we had. So anybody has any, again, type it out or say it. So where is it? Look at it in the map right here. Continental or maritime? Everybody sleeping still? Oh, nowadays with you can go to sleep and I can't see it, right?
Isn't it continental?
It is continental. Yes, Celia also said, and then Pedro. So it is definitely continental. It means that it's away from the ocean. Remember what we said about patterns that we have when we're away from water? Is
Yes.
usually the ranges of temperature are usually going to be more drastic. The range of temperature is going to be wider. That means that it's going to be very cold in the winter, like you see here in January in St. Louis, Missouri, and hot in the summer. Remember that if this was say San Diego or Seattle, it would be very different because the curve wouldn't be as steep. There would be a bigger. There would not be such a range of temperature. So again, this spinograph visualizes allows you to see detail and the patterns of precipitation and temperature in a given place. At the bottom, you have these bars that you see right here in blue or violet, whatever color they are. Those are the levels of rain that you have on for a given month. So if I was to ask you when will you see the most of the rain in St. Louis, Missouri? What month? You know, right
In
now.
March? Isn't it
Well,
March?
March, of course. Yeah, March will be the largest one. So most about 5, 6, 7, somewhere about 6 or 7 inches of rain in March. So yeah, so March is definitely going to be the rainiest month in St. Louis, Missouri. And so you can see the pattern. It's relatively even. Seems like there's a lot more rain in the winter than there is in the summer, but you know, summer months tend to be relatively. But at the same time, it's not extremely rainy. Right? It's not. We're not talking about tropical for sure. So again, so again, at the bottom is when you see precipitation, the chart over here. Once you get used to doing this, like I said in the lab, we do a lot of these and we analyze them and you can kind of see patterns. So haven't seen a lot of these. I can know, just by looking at the chart, by looking at the graph right here, the red graph, I know that it's continental because it's a big range of temperature. Even if I don't know where the place is at, I can tell that it's going to be somewhere away from the water, just simply because it's a big curve. And the same thing, I will know a little bit that the precipitation variants are a little bit different than others. Now, you can see right on the corner over here, the one that I'm pointing at right now, that's going to be the actual full-on climate classification. We know it's going to be a D climate, which is a severe middle climate, and then in terms of precipitation. That's the actual climate right there. Tells you the location, and again, but the most important is the visualizes it, the graph, and then the precipitation bars helps you classify. So you can see it so what I'm going to be doing in a few minutes, I'm going to be going through different climate regions, and I'm going to give you examples of some places within that climate region, and I'm going to show you the climate graph that they have for that place, and again, you'll be able to see the patterns of that place. And so each place is going to have its own unique climate that exactly indicate what happens in that particular place. Um, so yeah, a lot of people when you travel, sometimes is if you go look and say nowadays you can go on the internet and find out the conditions for that particular place. Should I, bring? Is it going to be cold? Should I bring coats, or is it just going to be short or pants temperature patterns? So it will be helpful visualizing what's going on in terms of temperature patterns. Right? The question about climate graphs. So we're going to be seeing a lot of these. When I go, I'm going to take you around different regions of the world. I'm going to show you what's going on in there. Okay. Now, here's the global classification pattern around the world. We are going to look at these. Each of these it has a classification. Each of these has their own unique place. So you can see what I was telling you about right here, the red, those are our classification. This particular one down here, it actually extends all the way down towards Mexico, towards parts of like San Quintin. As far as that is kind of where you're gonna see this Mediterranean climate. So you can see also, of course, that it gets the name from being around the Mediterranean, southern part of Spain, Italy, Greece, all those beautiful sites that you see. Very unique. Around the Mediterranean, us, some portions of Chile, around Valparaiso, have that same type of climate. And the tip of Africa, as well as these corners of Australia, have the same type of climate that we have. Again, like I thought, very unique. I'm not going to go through these, but this is sort of what the climate classifications are distributed around the world. Now, this is also going to be reviewed. The next thing I want to talk about. Remember the controls that I was talking about? We were talking about temperatures and that kind of stuff. There are certain things that determine the type of climate that you have. And I guess, you know, even from basically from the first chapter when we're talking about latitude and longitude and all that stuff, we said that basically was knowing where the place is at, it kind of tells us where it's at in the world. It can tell us a little bit about what's going on in that part of the world in terms of of climate. So let's review what we call climate control. These are the things that determine what type of climate we have in different places. Again, when we see the distribution of this climate, we already know some things about this. We were talking about a tropical pressure system, a high pressure system that sits out here. Right? Well, that determines usually by areas. We have them here as well. On the west side of continent, remember, we always have on top of the tropics, that's where subtropical comes from, we have, that's where the deserts are at. Those tend to be really dry areas. Areas around the ITCZ, around the equatorial region right there, that's where all the tropical forests are at. Those are very rainy areas. We know they're always going to be warm. You know, direct rays of the sun always hitting that area. This area right here. It is also because we have a very big low pressure system, the ITCZ, that it constantly rains. You know, year round, lots of light, lots of daylight, and then usually, but most of the time by the afternoon, early morning, it's going to rain. So that place is rainy and hot. And so we kind of know some of these things already. So let's review the things, the factors that control climate. And again, this is review, but it's important that we sort of study them now in the context of climate classification of the climate. So what's the number one? Type it out. I haven't put it up there yet, but what's the very number one factor that is going to determine how hot or how cold a place is? Yeah, of course, location, but how do we? Yeah, there you go. You got it, Celia. It is remember latitude. We're talking about 0 at the equator, you know, going all the way up to 90 degrees up on top, and then what we call the higher latitudes, right up there, right? So definitely latitude. The closer you are, remember, lower latitudes are by the equator. So the closer you are to the equator, that's going to be a low latitude. Higher latitudes are going to be closer to the polar region, again, both in the North Pole and the South Pole. Definitely latitude. Latitude is the number one factor that determines climate. Remember, like I said, it's not the only one, but it's you can never go wrong. Understanding where a place is, knowing where a place is in terms of latitude, location, like Carlos mentioned, geolocation, right? That is usually determined by latitude, of course, latitude and longitude as well. But latitude is definitely determinant, the number one factor to determine climate. Oops, I put it up there. Anyway, I was supposed to hold it. But the second one is what? Elevation, right? Remember what I said? We talked about this before, that the higher you up in elevation, is it going to be colder or warmer and higher elevations?
Colder.
Colder, right? So the higher you go up in elevation, the colder it's going to be. So elevation is number two. Now remember that you see the H's over here. These are usually areas of mountain. So that's why they create a whole new classification system, because here in Europe, when you see the picture of Europe here, you know that these areas around here have mountains. I mean, in Africa and in Europe up here, you see the Alps, right? So those areas have pretty much their own specific climate. So elevation is definitely important. The higher you up in elevation, the colder it's going to be. What's the third one?
It's land or water contrast.
Yeah, so and remember we call that continentality, right? How far you are from the water. So yeah, so what happens if you are on the coast? What's going to happen to temperatures? Are they going to be big ranges, or are they going to be pretty mild? You think of our area, right? We live near the coast, right? So think about that way. So it's going to be, yeah. So it's going to be warmer, but remember that it's not going to get really hot. Just again, think of San Diego. Just in the summer when it's supposed to be the hottest, you'll get the fog. So the water regulates it. It always mild. Remember we talked about the reason water takes a lot longer to heat up, a lot longer to pick the cold. But like right now we end in the winter, so right now the waters are pretty cold. But in California, it's normally cold because we have also a cold current that goes through. Uh, but it keeps it mild there. The ranges are not going to be that wild. But like what I showed you earlier with Missouri, that is in the middle of the country, away from the coast, the ranges of temperatures are going to be really hot in the summer or really cold in the winter. Cold there anyway. So big range, big variation. What's the next one? I briefly mentioned earlier as well. We talked about it a lot in chapter 5. What's what
Ocean currents?
I'm kind of tired of somebody wants to make some comments, huh? Who that? Anyway, so yeah, Petra, ocean currents are part of it. I'm trying to kind of keep them in order. What would be, say, a little more important in ocean currents? Remember the one that gives us deserts in West Coast, and what do we have sitting right out in the ocean over here in the West Coast near California? Yeah, ocean, something is even a little more important. What gives us dry conditions right here, or on like in the map that I'm showing on the right of Africa, something that sits right over here. Wind also is a factor, Celia, but I'm trying to keep it in order of importance. Well, and one is related to the one I'm trying to get you to say. So
I'm not sure.
So Celia, what results from you mentioned wind, right? What causes wind?
Heat and
Guess forgot already? It's like a long time ago, but so what causes wind?
isn't it heat and humidity? No.
Yeah, I know people forget. That's why I'm doing this review. Well, ITCZ, but that's gonna be in the equatorial region, right? So, but what is the ITCZ? What is type of I'm trying to get you to take it without giving you the answer. So, what is the ITCZ? Is something or something something? What is the ITCZ?
Hold on, let me look at my book.
What
atmospheric circulation.
Was that?
I said atmospheric circulation.
Okay, but what causes it? What do we have in the ITCZ that what we have here on our coastal region here? Well, you guys, yeah, is most of you have it. You're almost warm. You're getting there. What creates the ITCZ? We have something really massive that creates the ITCZ, and then it actually creates something that we have right off on our coast over here. My God,
The Hadley cells?
what that?
Is it the Hadley cells?
The Hadley cells, which are what? What are the Hadley cells? Remember the balloon? Greenhouse gases. Remember the balloon? Something goes from
Oh,
something.
it's yeah, the pressure.
Pressure. There you go. Pressure patterns. All these things that you mentioned, right, are created by pressure patterns. So we do have a high pressure system that sits right on the ocean over here that gives us wind, right? Like Celia mentioned. Yeah, remember that we have the spinning that happens because in a circulate in the high pressure system we have an anticyclonic pattern that gives us at least where this high pressure system that sits right on the coast is spinning. The spin is clockwise, so we get winds coming from the coast. We get winds coming from the west and westerly, right? The ITCZ again is part of. We have a low pressure system that sits there. Again, in there we have warm air that is rising, and that remember that adiabatic process we talked about in chapter 6. That allows for the warm air to rise, create clouds, and so that place is going to be really rainy. The Hadley cells, yeah, there's the massive cell system that gives us a low pressure in the equator, but then when all that warm air that is rising goes up to the high levels of the atmosphere. Once it gets up there, it gets cold, and then it descends right where we are, and now it becomes. I remember colder sinks is giving us a high pressure. All right. So in the next one, it relates to pressure patterns, and Celia mentioned earlier. So it wind patterns. They also matter. Now they are tied in together. They are created by pressure, but these pressure patterns are going to create, either low pressure system that we find in the tropical regions of the equator, or high pressure system that we have sitting like in the mid latitude level we are. And when we talk about it before, but in a different context, when we're looking at the patterns of global circulation, wind patterns around the world, they all depend on these different types of pressure patterns. But now, so where the wind comes from, it also matters because the fact that, like I was telling Petra earlier when she asked that question, what we have here in the fact that we have winds coming from the ocean bring us moist. The winds come moist. They're coming in from the ocean, and they're going to be cool and moist, because we have the ocean current. But and so that makes a difference as opposed to say if you're in the Midwest, right? Again, the winds all through the United States are going to be coming from the west. It's just the way they move here in the United States. Those wind patterns are when let's say if you're in the Midwest, the winds that they're going to be going through the Midwest in the summer, they're going to be hot, right? They're going to keep moving to the East Coast. When they get to the East Coast, the winds in the summer, they're going to be warm. The winds are going to be coming out very, very warm and dry because they're coming from the center of the United States. In the winter, the opposite. In the winter, the winds that are coming from the west, from the Midwest, are going to be really, really cold because the whole area is cold. So the East Coast is going to get all those winds that are coming from the Midwest that are really, really very cold in the winter. But for us, it's basically what we deal with is basically the moisture that comes from the ocean. That's why we get fog in the summer. We would be just like in the deserts if we, because we're at that latitude, we have a pressure system, would be just like that, but we happen to have the ocean that is blowing winds coming from the west that bring moisture, and that gives us the fog that sort of cools things down, makes it a little milder. Right? What's another one that I mentioned before as well? Pressure and wind are together. We're going to get to the last one that Petra mentioned that somehow has to do with pressure systems as well, but not so much. What's the other one? Think of the age of the age classification, or the difference between, say, here, where we are here. See,
Okay, location?
well, we already talked about that one, right?
Mm.
We talked about latitude, right? But
Latitude.
again, think of the highlands, things of high. What and we already talked about elevation, right? But
Uh-huh.
there's different patterns of elevation. What happens? Why are some areas higher in elevation than others? What do we call that? What do we call that?
Topographic
Study that
barriers?
on chapter 13, but it's topography. I'll help you out.
Topography.
Topography, basically the type of mountains that you have, if you have hills or if it's flat, those things are going to determine whether, if, you know, the elevation that you have, they're not related. We talk about pressure pattern, wind pattern, that also determines ocean currents. And now ocean currents are sort of work on their own because they also move around within the specific parts of the world, and then most of them based on other factors, mostly about the fact that the Earth, remember that the Earth is rotating real fast, and so the Coriolis effect, all those things we talked about before, they all relate to ocean currents as well. But so anyway, so all these things are tied in together, but and again, I mentioned Genesis review that tells us what, and that's what we call them controls of climate. What actually controls the climates that we have? What determines the temperatures that you're going to have, which again, one of the things we make sure to classify climates, and of course, the other one is precipitation. So these are important to understand why some areas are going to have more rain and why some areas are going to have different. Right? I remember there was one that I mentioned. There was a mixed category, so like miscellaneous categories. Topography was one of those. You know, island areas. You know, we have even here that when we have mountains, that we're gonna have a windward side, like that it's gonna be wetter and say an alpine, than it's gonna be an El Centro or, you know, an Imperial Valley. So all these things matter. What I'm gonna be doing now, I'm gonna be taking you to different places where the main groups are happening. Particularly with Group A and Group B, I'm going to mention some of the subcategories briefly. Again, I don't expect you to know the numbers or the letters, but I will explain some of the differences relatively quickly. But what you do need to know is the general category, general patterns that we find on, say, Group A versus Group B. Right? So I'm going to focus on those, and that's what I want you to know. Okay. So let's take a trip around the world looking at this climate patterns. So Group A is the tropical humid climate. Right? In general, that's what those are. They're basically, most of it gonna be in land areas, right? Again, remember, water, the oceans have different patterns of climate. When we talk about the adiabatic process, we were talking about what happens on land. You know, water has a whole other pattern as well. So we find the tropical humid region. Remember those 47 degrees that I keep talking about? 3.5 here, 23.5 in the southern hemisphere. We have tropical Cancer and Capricorn. So we are up to 2 and it's 47 degrees. So tropical humid climates are going to happen within that range, 47 degrees between the tropics, right? So again, there are going to be some areas that have mountains. So we have, for instance, over around the equator, we have the Andes. They go right through it, and just simply because they're higher elevation, you know, have a specific patterns of temperature. Right? Now, what basically makes this category unique is it's hardly going to be cold any time of the year. So that's why people go to the tropics, and you're in the middle of the winter in New York, and you can go to the Bahamas, you can go anywhere in the Caribbean, and it's going to be warm year round. And it's always going to be rainy, lots of moisture. It's going to rain quite a bit. Now, there's going to be differences, and that's why we're going to break down the specific categories. based on the amount of rain that they get on a given year. That the A to F, the AF category is where the tropical rainforests are. That's why they are in there, rainforest. Amazon, the ones that we find in Congo region, the Congo Basin in Africa, Indonesia, all those areas, again, that's where the tropical forests are. Those places are raining every single day, most of the day. It's raining. It's always raining. It's always going to be very wet. Lots of vegetation, lots of humidity because it's always raining. The savanna is also part of that. It's within those 47 degrees, part of the tropical humid A category, group A. But there's going to have a different pattern of precipitation. It rains a lot, but C is more seasonal. I'll explain in a minute here. Then we have what is called the tropical monsoon, which is only a few places that will have it. And those are simply variations when the ITCZ moves north. It brings pouring rain into some of those areas. So whereas the tropical wet is basically raining every single day, 2-3 times a day, savanna and the monsoon are more seasonal. It's not always rainy, but when it does rain, it really pours in those places. Now, something to say really briefly about what we hear in terms of daily rainfall. Remember that here's the pattern of heat that you have on a given day. Usually, again, the peak of the heat is going to be sort of around noon, but the hottest time of the day is usually going to be between 3-4 in the afternoon, right? And so it's usually like that. Sometimes it won't be unusual for rain to happen. Remember, usually that's going to be more condensation when it's cooler, so it's not unusual for it to rain in the morning. And then later in the afternoon, it will rain again. Sometimes it will rain overnight, but it's always raining in this area. So again, these are the general categories, the general patterns that we find in climate and the group A. These are called the tropical humid climate. Again, a few things that you may want to remember that I may ask you in the type of an exam. Where does that usually happen? Again, remember those 47 degrees between the tropic. That's where it happens. Lots of very little, it never gets cold in there. With few exceptions in the mountain area, but for the most part, it's going to be wet and warm. Right? So I'm gonna take you again, and I'm gonna probably do this a little rapidly. Again, I don't expect you to know the specific characteristics of the AF versus the AW and AM, but sort of just take you, literally I'm gonna take you there in some space for you to take a look at this. So here's the AF. The AF is that tropical wet, always warm, always wet. Again, here's this is the area that is right by the ITCZ. It's a low pressure system that is always going to bring you rain. Some of the controls that we have here that bring you this pattern of warm temperature. Again, if we already talk about the ITCZ, we have a lot of convection there. The rays of the sun warm it up, and then they're gonna eventually it's gonna rain. We get winds that come from the east for the most part, trade winds, and they usually bring in really moist air from either the oceans or the seas that are around it, big seas that are there. Here are some of the climographs that you can see over to the right. Here's I have one climograph for Singapore that I'm sort of pointing out right now. Right? Again, look at the line. Look at the graph of temperature. Flat, right? It's always going to be warm. It's always going to be somewhere around 80 degrees. Now, the other thing is you're hardly ever going to see like 110 degrees or something like that. It's going to be somewhere between 80 and 90 degrees year round. See the same thing. Iquitos, Peru is a little bit on the southern hemisphere. So what you're going to see is that the patterns switch. The curves usually look the opposite. And it's not very noticeable here because it's pretty flat, right? Iquitos, Peru is, I'm going to show you, I'm going to take you there in a minute here. It's actually it's at the mouth of the Amazon basin, it's the entrance to the Amazon, right? And you can see the patterns of rain. I mean, look at it year round. I mean, It rains in Singapore, for instance. It rains a lot more in November, December during the winter. But I mean, we're still looking at about over 10 inches of rain um, um, in any given month. But the average is going to be higher than 10 inches of rain. Look at Iquitos, Peru, the same thing. It's pretty much rainy year round. Some a little more, like March, where they can get up to, what is it, about 12, 13, 14 inches of rain for the month. I mean, think about it. We get 1 or 2 here and we are going crazy, right? You can see that in these places when you're looking at 10, 12, 13, 14 inches of rain every month. It's lots and lots of rain. Lots and lots of rain. So again, some of the other factors, again, here's where you have the tropical rainforest. This is the rainforest of the world are here. This is where they are. They're going to be in the Amazon. They're going to be in the Congo Basin in Africa. They're going to be in Indonesia, the rainforest of Indonesia. High humidity. And again, the main reason is latitude, where they are, where they happen to be at. They happen to be right by the equator, the 47 degrees. You have high declination. Again, the rays of the sun are very direct, high angle, and remember, what happens in the equator is that they're always going to have 12 and 12 hours of daylight. 12 hours of daylight, I mean 12 hours of daylight and 12 hours of darkness. So you can always guarantee that in the equator, you're always going to have at least 12 hours of daylight. And so again, the more daylight you have, the warmer it's going to be. So those are the factors that determine that. I'm gonna take. You want to go to Iquitos, Peru, or you want to go to Singapore? I always ask that.
Peru.
Let's go to Iquitos. Now, Peru, the actual entire country of Peru is very dry. It's a very dry place. But Iquitos sits right at the mouth of the Amazon River. It's still Peruvian part, but they call it the Peruvian Amazon. And Iquitos is always called is referred to as the gateway to Amazon, the Amazon River. I was there a few years ago, and it's an amazing place. It traditionally, because it is at the mouth of the Amazon River, has been a place for like even the time of discovery, where the final people they could go deeper into Brazil, and usually that would be the entrance. Today is probably not right now, but it's also like a big tourist place because again, most people there's all kinds of expeditions. You can take trips. You know, if you want to go through, not necessarily go across the Amazon. That's a long process. They do have tours that take you all across the Amazon. But people that want to go to the Amazon will come here to go there. Let me show you some pictures. Most of these, a lot of these pictures that they show here, sometimes they tend to be, they show you, they show it always on the nice days, right? And trying to get tourists to come in. Kind of, of course, it's still have a lot of remnants of the colonial era. And of course, there are more modern places than that. You see these a lot, much, right by the Amazon River. You see a lot of these patterns, lots of water everywhere. Most of the time, it's going to be somewhat cloudy, and you still see it. This is really interesting. You see a lot of these old colonial. I mean, even like today's a gateway to Amazon. It was then, and so a lot of the conquistadores or the colonial people would come in and build churches and very much interesting sort of colonial type of place. It is Peru. It is a developing country, so not going to be luxurious. Although there are some new places that probably were not there when I went, but that are appealing more to tourists. They have actually when I went, they actually stayed in a hostel, and my former boss was Peruvian, so actually I went with them, and but his family lives in Lima, and so I was actually staying at a hostel, and feeding some people. Oh, the dogs are fighting. Anyway, so yeah, so it's a kind of a really interesting place. But again, this is the typical pattern of climate that you're gonna see in that place. There you go, some orugas. You can eat those. But anyway, so that's a little bit about Iquitos, places. Anyway, so the next one is what is called the tropical savanna climate. So again, with the AW, you now have different patterns of precipitation. You can see the climate graphs to the left. We have Acapulco, Mexico as an example. What basically happens with in a savanna climate is that it's going to be a rainy season and it's going to be a wet season. I mean, a dry season and a wet season. And so what happens here is that the ITCZ moves. So in the summer, it's going to be a little bit near it. Again, these are not necessarily at the equator, the ITCZ right at the equator, but the ITCZ moves up a little bit in the summer, particularly in the northern hemisphere, in the summer, and of course, summer is different in the southern hemisphere as well. But when the ITCZ moves nearer, the region is when it's going to be raining. It usually happens in the northern hemisphere. It happens in the summer. So in the summer, it can get very wet. And it'll tend to be where the ITC moves away back to the equator where it usually is in the winter, it tends to be dry. So they're basically going to be alternating periods of wet and dry. So, and then mostly because of the ITCZ moving up or down. Anybody been to Acapulco? So if you've been to Acapulco, you'll know that. If you haven't been there, I mean, of course, nobody in it right now, but actually, I've heard, I was watching the news in Mexico that that a bunch of crazy people still went for, usually Cuaresma, the Semana Santa, everybody goes there and it packs, everybody from Mexico City leaves and goes there. And apparently, with tons of people basically finding all there in the same places. I don't know how it was here. I know Ensenada and Rosarito get crazy as well. I don't know if anybody went down there. I'm supposed to, but I know people do anyway. But they were complaining. In fact, at some point, the police was moving people around, and they were at the airport. We're not letting foreigners come in. Like a lot of Americans, they go there. They would tell them you can't come in, or they send them to a hotel, and then you have to go back. And so, tourism were not very happy. I heard all kinds of crazy stuff going on. But anyway, so again, you can see the climate graphs. In Acapulco, for instance, you'll see that the rainy season is going to be in the summer. Lots of rain, up to like 15, 16 inches of rain in September. And again, summer months, very, very wet. Almost no rain in the winter, right? Now, in Normanton, Australia is the opposite, right? Because the summer is different. So the summer months are going to be January, February, March, but it is still, you can see still the huge amount of rain that they get in the summer, in their summer, very little in their winter. In fact, almost none in the winter. And now you can see the temperature patterns is still relatively flat, made typical of the 8 climates. Again, with the variation in Australia, that is the opposite. The curves usually are moving up like that in the northern hemisphere. They're sinking down like that in the southern hemisphere. You want to go to Acapulco or Australia?
Australia.
Okay, let's do Australia. And
I've been to Acapulco, so let's go to Australia.
I'll put Acapulco also for people that haven't met.
Okay.
So here's where the area that they're talking about in Normanton, right around here. There's all kinds of factors. We get in the southern hemisphere, the winds, the easterlies that we usually get here, well, they're going to come from the west. So they get winds that are coming like that, and this brings a lot of moisture from the oceans over here. So that moisture again, usually when the ITC goes south a little bit, it comes from the equator, moves south, and it's going to bring a lot of the moisture in their summer months. Now again, some of these always put the touristy places, but so and again, you'll notice this in Acapulco as well. There are places that look like this, kind of dry, Obviously, this is going to be perhaps the winter when it's not that rainy. And like I said, most of the time they're going to try to put pictures of when it's nice, right? So people go out there. But this is very typical. But it's not totally tropical, lush vegetation like you see in the tropics. But again, you still see a pattern like that. Teresa, let's just show you a few more. Perhaps better area. Again, they just showing a lot of touristy places here. Some of these are pretty helpful. That, and I put these because some of them can show you a little bit of what you see. I mean, again, it's not definitely lush tropical, but again, in the winter months, I think this might be kind of winter where you see a lot of water in some of those areas. Yeah, let me. Well, now I want to show you. Let me show you Africa. Here's a picture of the tropical savanna that you see in Kenya. Now this is, and I'm going to show you a national reserve that is. The savanna is also the type of climate where you see lions and that big fauna in Africa. That's what they roam. They usually a large portion of Africa has this type of climate. Again, it's called the savanna. The type of biome, the type of vegetation. And that's again where you're going to see the typical lions and that roaming around. Let me show you. So this is a national park, and they're having a lot more. Talking about this in my world geography. They're having more and more of these national preserves, and mostly to try and keep animals from being poached. Elephants are being poached for their tusks and rhinos and so on. So again, this is kind of the pattern, very similar to what you saw in Australia and what you see in Acapulco. Of course, Acapulco is in the ocean, so it's really different. But again, this is the place that you're going to see, and animals tend to migrate based on the rainy season. And so when it's dry in the winters, they're going to move to areas where it's a little more water. And then once the rains come back again, they come back and places they can get more food and so on. But the savanna, this savanna climate is again where you see the big fauna, in Africa. The very typical pattern of again, it is again within those 47 degrees. It's a little different. And you can almost see, this is probably during the rainy season, you see a lot of green grass. And you see massive stampedes of I don't know a lot of these names of some of these animals, but they literally, you have these huge groups of wildebeest, I think wildebeest are called, that they just follow the water. And they usually go on to find places that just recently rained. When it's too, like this guy, they go across looking for the water where the water is high. So when it rains, they're going to be hanging out in the area where there's a lot of water. When it gets dry, they're going to have to move somewhere else to find the water. Because this is a very typical pattern of the savanna type of condition there. It's like that. Not tropical, lush tropical, but particularly in the rainy season, it's going to be a lot more water. Now, let me show you briefly Acapulco and all. See it. I actually never been to Acapulco. Again, a little bit of a difference here is it's going to be, because it's closer to the water, it's going to have a little bit of a different, microclimate type of thing because it's just where it happens to be at. But, if you go further inland, you're going to see a lot of the patterns that you saw. In the dry season, it's going to be a lot more drier conditions than they are in the. Again, here they're going to show you a lot of stuff. You can see you up in the hill. And again, it's not necessarily tropical. See some of the hills over here, but they're definitely a lot lusher in the rainy months in the summer. But again, here they're trying to actually show you where it's nice. But you see that kind of vegetation pattern. Very typical savanna type of condition. So yeah, I got to go to Acapulco one of these days. Although I hear that it's getting really insecure. There's a lot of violence in Guerrero nowadays. They used to be, the narcos used to tend to try to, I guess, prevent going into places where there's a lot of tourists. Nowadays, they don't care. I mean, Mexico City starting to have a lot more cartel violence, but someday I'll go out there. All right. Okay. So again, that's the tropical savanna. Again, here's what happens. The ITCZ moves, in the northern hemisphere, it moves up, a few degrees north, and in the summer, in the southern hemisphere, it moves out a few. So usually the ITCZ is right over here, right around the equator, but it shifts. And so that's what causes the really rainy and the dry patterns. Now the other one, very similar to it, but a little more drastic, is the tropical monsoon, which is the AM temperature. Very, very wet. And what basically happens and I think we briefly talked about it before, say places like India, where in the summer, because of the ITC moving north, a lot of the winds that are going into India are coming in from the Indian Ocean. So they're moist and they're warm, and so they bring a lot of really, really wet conditions. And you can see the contrast. I mean, it's exaggerated. The two places where they have this monsoon weather in the summer months, right? Both of these happen to be somewhere in the northern hemisphere. You can see, I mean, exaggerated. We're talking about what, off the chart, 30, in some cases, 30, 40 a month in those particular months. So during that period of time, it just pours. You can see the climate patterns in terms of temperature, they're pretty flat, very typical of this region of the world, this climate. Warm, pretty much for the most part, but just notice the just exaggerated amount of rain that you get in the summer. Again, this is basically caused by the ITCZ moving up. Somebody else have a question? Yeah, so what happens is basically in India. Now, here's the deal that, like I mentioned before, that in India, in some of these Bangladesh areas, because it's dry during the winter, they, and because there's huge population in India, over second largest in the world, about 1 point, I think they went over 1 billion, 1.1 billion. They're pretty big out there in terms of population. And a lot of the agriculture is still very traditional with, canals, using canals for irrigation, relying on the rain. So if they don't get a really good monsoon season in past years, I mean, they're still having them, but in past years, there will be millions of people starving to death because they didn't have food. So the monsoon, even though it's huge amount of rain, causes flooding, people die with all this crazy flooding, but they need it because otherwise they're not going to have water for the rest of the year. Let me take you to Bangladesh. That's of India. This place, because it's also really low in terms of elevation, it tends to get heavy flooding in the monsoon years. You can see that again, very lush in terms of area, in terms of vegetation and so. But definitely, and again, unfortunately, a lot of the pictures here, they're just trying to get you to go there. It's very touristy, so very few are going to be directly from in the monsoon season. You can see that there's a lot of water.
Oh, that's beautiful.
Yeah, and this usually comes. In fact, this is probably, I can tell you, it's probably in the winter, because these type of movement of water in the rivers are usually going to be the rivers like this one right here are going to be pretty full with water that usually resolves mostly in the winter. There's a rainy winter picture, or I mean summer picture. You don't see many of those again because I'm trying to get you there. So again, you see a little more of the large vegetation, that kind of stuff. Yeah, because when here's another one. When it rains, it really, really rains. It really pours. So, and I think I show you in when we're talking about precipitation, basically what happens in India, that is actually floods and stuff like that happens. So, anyway.
Oh, that's nice.
Anyway, so I think we're getting close to that. But anyway, those are pretty much all the wet climates, the tropical climates. Again, I mostly want you to know what you need to remember from this: very wet, very warm, year round. Doesn't really change that much. So you can see that the formulas I'm going to show you pretty much flat graphs because it's always like that. Temperature's always going to be like that. There are going to be a few differences with the AM and the AF climates, uh, where the savanna and the monsoon, that, that the rain patterns are a little more seasonal. But in general, those areas are very, very wet and warm. Now I'm gonna stop right here. We're gonna start getting into the dry climates on Tuesday. We'll probably finish. We try to get to finish this chapter on Tuesday, and we'll take it from there. So hang on for a few minutes so I can take roll. See who's everybody here. I'll let you go. You can ask questions while I'm doing this. Type them up or just simply unmute your mic and if you have any final questions. Here, just as soon as I take roll and then I let you go. It's very quiet nowadays. Getting cabin fever yet? No?
What was that?
Is there anybody getting cabin fever yet?
Yes. OMG, I can't take this anymore.
It is, I don't know, my patterns are just weird. I mean, days like, I try to keep a sort of a pattern, a normal pattern that we normally have, but it's hard. Like, some days I just end up being able to go to sleep and, I start reading something and trying to, go to sleep until 1, 2 in the morning. I have to get up early. And then other times I'm waking up at 4 or 5 in the morning,
Same here.
It changes.
Just
I've been reading a lot of there's science about it. I was talking earlier about people having weird dreams and it's a little bit of science to that.
yep. I think it's a little extra hard for people who loves to be outside, like hiking,
Yeah.
doing sports or whatever,
The weather hasn't been that
It's,
good, so it's kind of. But as the weather starts getting nicer, people will get, hey, I want to get out of here.
yeah, I'm one of them.
Yeah.
Yesterday I went for a walk to Coronado Beach and I was like, you know what, I don't care. So me and my daughter, we just took off and we just exercised for a little bit because this is too much for me.
Around. Let's see. Seems like we're missing people today. Lots of people. What do people do when they just don't get up early, or maybe that's what I was talking about earlier?
They're still sleeping.
Let's see. I think I gone to about everybody who I got here, but yeah, a lot of people are not here today. Check out very quickly. Good to see you, Andrea. Oyes, Andrea. Yeah, so I'm just gonna briefly, yeah, there's some that haven't been here for a while, but no Felipe Avila, right? If you're here, you need to tell me because I don't see you on the list, and I'm just assuming you're not there. No Aviles, no Diana, no Joshua, no Aldo. No, Carlos Elizondo, are you there? Yeah. Hi, Andrea. Yeah, you there? Okay, yeah. I thought I saw you earlier. Let's see. Alejandra, I don't see you. Alejandra Gonzalez. Once. Jessica, I don't see you out there. If you're there, you need to say something on the. I don't see Kevin. Miguela. And Daniela Perez. Lisa. I was asking earlier, did anybody know what happened to Lisa or Laura Ruiz?
No.
And no Grecia today. What happened to Grecia, Andrea? And no Villanueva, you're not here. And Leslie Velasquez. Okay. Guys, I think that no Yari. I don't see you either. Are you here? Okay, no Yari. All right. Again, you guys. So hey, that was it, and we'll be seeing you on Tuesday. Again, don't forget the app quiz. That is another thing that. Okay. So take care, everybody. Be safe.
Take care. Thank you, teacher.
Okay, take care.
Bye-bye.
Thank you. Bye.
Take care. Okay. All right, so I'm going to stop the recording.